So did anybody have any questions about the homework?
Nope.
No, I
No.
didn't either.
I
Did you
like
have
the
any questions?
videos.
Yeah, the video was really nice.
Yeah.
Amy, did you have any questions about the homework? No, okay. And you were good too, Kelly?
Yes.
Okay, awesome. So I guess we can go ahead and start with the assignment if no one had any questions.
All right. Cool.
Okay. So does someone want to start with number 3?
Mhm.
Okay.
That's number 1 and 2 are on our own conscience.
Yeah.
Yeah.
Sorry, what was that?
So 1 and 2 we just answer on our own, so we're just gonna go to 3. Sorry. Let's see if I can. It's up all the way. I don't know how to. Okay. I'll just hold it really close. I don't know where my speakers are. Oh, they're right there. Okay. All right. Cool. I
Um,
can read number 3 if you want.
okay, awesome.
All right. Give all your probability answers in as decimals. For example, okay, yeah. Anyway, human blood can be classified into one of our basic types. Sorry, I can't think with the sirens. O,
Oh, like,
A, B, and AB. The proportion of people in the population in the United States with each of these blood types is summarized in the following table. Use this data to answer the following questions. The blood types and proportions given in the table above define a probability distribution.
okay.
I believe that's true.
I was thinking true, yeah.
Because if you add all the decimals up, we'd get 100%. So, yes.
Is there any way you can find Mom's glove for me if it's in the closets? Then I can have somebody else use it tonight because we were short gloves last week.
Oh, I'm in the middle of my group meeting, so
What?
maybe later.
Yeah, I know. Just before sound.
Okay, we'll put that one down as true.
Yeah, I'm pretty sure 3 is true. You want me to read 4? Sure.
Yeah.
Okay. What is the probability that a randomly selected person in the United States has type O blood, rounded to decimal places? So it would just be 0.45. Yeah, I was going to say it gives us the answer. Easy.
What was that last one? I can't get on the island, so I'm just
Okay.
on it up there.
I'm just going to put her up to my ear so she can hear what I'm saying. So it just wanted to know the probability for people with type O blood. And so the proportion, it says 0.45 under O, and so it's 0.45.
Okay.
So number 5, I'll read that one. What is the probability that a randomly selected person will not have type O blood, rather than nearest 2 decimal places? So that will be 0.65, right?
No, 5.5.
Oh yeah, 5.5.
Yeah. Did you get that? I was going to say, if we wanted to do this the complex way, we would add up the 0.40, 0.11, and 0.04. You just subtract the 4, 5 from 1. Yeah. All right.
The 0.55, right?
Yes. And then, someone want to read number 6? Sure. Carolyn Wallace and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tangle, one of the dogs, demonstrates The identification of a specimen. 7 bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. If the dogs guess at random, what is the probability that they will correctly identify the dish containing the specimen for the bladder cancer patient? Round to 3 decimal places.
So 7 bowls, only 1 is cancer, and so then you would just divide 1 by 7, correct?
Yes. So it would be 0.143 because we're rounding to 3 decimal places.
So yeah, I wanted who did?
Yeah.
Wait, what did you get?
0.14285. Yeah, 143 is what I rounded it to.
Okay. So I want 4 decimal places.
Now it's 3. Round to 3 decimal places.
Oh, okay. Because at the top it gives an example and it says 0.1234.
Yeah.
So then
It's saying to give all of them in decimals. Don't, put 1/7. Put the 0.1423.
okay, got it.
That's why it says, for example, 0.1234.
Good thing we're doing this as a group.
Yep.
I'm a little slow today.
That's okay.
So 0.143. Did you get that, Amy?
Hey, little one. Hey, little one. You miss Daddy? Daddy?
All right. So, do you want me to read number 7? Is everyone okay with number 6?
Yes.
Okay, awesome. In a combined total of 54 trials, dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dog would do this well by random chance alone. Which of the following statements is most appropriate? There is little evidence that dogs can detect bladder cancer, or this provides strong evidence that the dogs can detect bladder cancer. So there's a combined total of 54 trials.
So do you guys know how to tell whether it's little evidence or enough evidence?
Wouldn't it be little evidence because it's not like in a high population? It's only like, I don't know.
I'm not sure.
Let's see. We go back to the reading and check.
Doing number 7, right?
Yeah.
Yeah.
Sorry, I got my island work.
Yeah, I don't know. Let's see.
I can't find it in the reading.
I can't either.
Yeah, I can't find it.
I don't remember going over that.
Here, one sec. I'm just gonna. That's my time.
So I guess at random, if they were randomly, so 1 divided by 54 is 0.018. That would be it at being completely random. And I'm thinking since they got it right 22 out of 54 times, that's about
It's like 40%,
yeah,
right?
40%, yeah. So I don't know. It's like it's less than half, but it's still better than random.
I seem to remember either 30 or 35 from last semester when I took this class, but I could just be making that up from something else way further in our lessons. Who knows?
The thing that I was looking at though is that it says it is very unlikely that the dog would do this well by random chance alone.
Yeah.
And so, like, that's why I was saying there's very little evidence that the dog can detect bladder cancer because it wasn't by random, apparently. It says that he wouldn't be able to do it by random chance alone.
So what do
You
you
have to already, like, have known the patient or something. Because didn't it say that it sat him down with the patient that had it first, and then he went to the P-Bowls or something? I don't know.
I don't know. This one's a tough one. Should we just, what do you guys think? I'm thinking maybe, oh man, I don't know. It's a tough one.
I mean, personally, I would think that's little evidence.
Little.
It is less than 50%. But
Sorry, I'm, like, playing a video. Trying to see if maybe it was, like, in the video or something.
Yeah, I remember watching the video. I don't think it said anything about that. I don't recall.
I can't remember anything like this.
Well, it says that it has to be 0.05, so less than 5% to reject it.
Less than 0.5%?
Yeah. So I'd say there's significant evidence.
I was actually thinking strong. I was thinking that was probably strong evidence too, just because at 40% of the time the dog was correct, and if that was up to complete chance, it would be a lot smaller of a percentage.
Oh, it's too big. Here you go. I'm back to you there. I gotta go off.
Alright, let me see. Alright.
You guys know how to do the next few for the M&Ms?
Yeah. Should we skip 7 and go on to 8?
Yeah.
Come back to 7. Okay. So number 8. M&M's are small chocolate candies and
507, I can't hear you.
Oh, sorry. We decided that we're just gonna skip and then go to the other ones and then come back to it.
Okay. That's like I can't hear you.
So 8.
Okay, so here we go. M&Ms are small chocolate candies. The M&M's website previously indicated that in the United States, the distribution of the colors in a bag of plain M&Ms is given in the following table. If you reach into a bag of plain M&Ms, what is the probability of drawing a red-colored candy? Round your answer to the 2 decimal places. So, guess we got that.
Wouldn't it just be 0.13?
Yeah, I was gonna say it gives us the answer right there.
But we have to make sure they all add up to 1. Does it all add up to 1?
Well, we aren't given green.
The green.
Yeah.
Yeah, that's just.
That's how we figure out the green is we add them all up and subtract that from 1.
Yeah, but there's still going to be green M&Ms in the bag, so we have to find green first and then figure out how.
But
Yeah.
that's
I got you. Yeah, that makes sense. 0.13. Yeah. All right, so everyone okay with number 8? Okay, number 9. What is the probability that a randomly selected candy is green?
I think it's 0.16.
Yeah, 0.16.
yeah.
So there's my 8.
Alright, so for 9, that's when we add all of them together and then subtract it from 1 so we can find the green ones.
Yeah. So I got 0.16.
Okay, and then number 10, we're supposed to find out what is the probability of not getting green. I came up with 0.84.
Mhm.
Yeah. And are we supposed to put 0.84?
It'll take it either way if you put the 0 or not. It will usually take it either way.
Okay, good.
If you just put 0.14, 0.14, either way it'd take it.
So
I've done
going,
it both ways.
so going back to number 7, it is strong evidence if it's if it said in the rules if it's above point or like 5%, then it's strong evidence.
Okay, so this one is number 7, and we're going to go down with strong evidence then?
Yeah.
Okay.
Did you get that? For number 7, we're going with strong evidence.
Okay.
Okay. I'm trying to think of where I put you near the computer where you're still in the video. Alright, so number 11. The ACT scores of students admitted to a medium-sized public university at Western United States were taken from CAPEX.com. The following summary statistics were calculated. Use the information from the public university to answer the following questions. So 11. Half of the observations are less than or equal to what number?
So you would get median.
Yes. So 24.
Yeah.
So 24 for 11?
Yeah. Almost done. Yay.
So based on the information on the table above, the top 25% of the students scored above what number?
That would be quartile 3,
Uh-huh.
27.
27.
27.
And then for 13, which of the following statements is not one of the rules of probability? A probability is a number between 0 and 1. If the probability is high, then the probability is positive. If the probability is low, then the probability is negative. The probability that an outcome will not occur is 1 minus the probability that it will occur. The sum of the probabilities in any probability is 1. I think it's B.
Yeah, if the probability is high.
Yeah.
Because probability is always positive and always between 0 and 1, so it's never going to be negative.
Yep.
All right, so we ready to hand it in?
Yep.
All right, let's do it.
All right.
Yay, we got 100!
There we go. Well done, guys.
Make sure Amy has all the answers.
Yeah, she does.
Okay.
Awesome.
Yay. That's exciting.
Perfect. I love probability.
Yeah. I think this homework was probably the easiest one.
I think so too. Yeah. All right. Well, since we're done, should we plan a time to meet next week, or I guess next couple days?
Either, yeah. Wednesday or Thursday.
Amy, can you not do it on Wednesdays? Is that what you said? Or
I can't do it Thursday afternoon.
Thursday.
I work.
okay, so then we should probably try to do it tomorrow.
Tomorrow.
Yeah.
Does like same time tomorrow work for everybody? 4:30.
I have class until 4:45. I can either do it before 3:15 or I can do it after 4:45.
Okay.
Before 3:15, does that work for like 2?
I can do it too.
So at 2, does that work for everyone?
That works for me.
All right. So we'll plan on tomorrow at 2.
Okay.
All right. See y'all tomorrow.
You guys.
Bye.
Bye.
Bye.